Math 3, Unit 2, Section 3. Today we're talking about solving and graphing absolute value inequalities. So similar to yesterday, but today it's now inequalities and not just an equal sign. Okay, so inequalities mean there's going to be some shading going on. We want to see where overlapping is happening. Some of you might have heard these referred to like as and or problems. Does that sound familiar at all? When you have the less than sign, this is and problems. I remember them because less than has and in it, and great or has or in it. So these are great or than signs, and these are less than signs. Now what that means is and means they have to overlap. It has to be this and that. So the answer to the graph is the overlapping portion. On or problems, it can be one graph or another graph. So or problems, they do not have to overlap, but and problems, they do have to overlap. Okay? So you'll notice here, and also with and problems, you write it as one single statement, and the overlapping is there in the middle. Okay? With your or, you have two separate answers, and it's like their shading is on one side or the other. And again, you could use highlighters on some of these. My highlighter is missing right now, just to show you where that is. But in case you can't see where it's shaded, so here these are shaded in the middle. Here these are actually shaded on the sides. Also notice that some of them have a solid circle and some of them have an open circle. So open versus closed, and they're open versus closed because of the, very good, the inequality sign. So this one has an equal to, so it's solid. This one doesn't have the equal to, and it's open. Okay. So there are some special cases with inequalities. Okay? So when we were dealing with an equal sign, the absolute value would never equal a negative answer, correct? Like when it comes out, it can't equal a negative. It will always come out and equal a positive. Inequalities, though, you have to be careful because there are special cases. So the way I think about this is you have like your variable, okay, or your x value, let's say here. So the absolute value of x, we know that that answer would be a positive, and this basically is saying b is less than 0, which means that b is a negative. Okay, so could a positive be less than a negative? No. So this one is no solution. Okay, now here this says that b is greater than 0, so that means that b is going to be a positive value there. And so the absolute value of x we know would always come out as a positive. And is a positive greater than a negative? Yes. And so this one is all real numbers or all solutions. Okay, does that make sense? So with inequalities, when you get a negative answer, okay, it's either going to be no solution or all solutions. And so you have to be careful because we normally want to always just put that it's no solution, but for some of them it could be all solutions if it's a greater than sign. Is that clear? Okay, we'll go ahead and move on, and I'm sure we'll get to see this more in some problems. Okay, so just like yesterday, we are going to graph, and then we're also going to solve it algebraically. So to start with here, f of x, where will we go first? What is my vertex for f of x? Very good. 0, -2. So notice how with the absolute value of x, there is nothing with it. So that's where I got the 0 part for the x value of the vertex, and then -2 for the y. So we go 0 and then down 2, make our point. And what is my slope for this problem? Very good. 1 is correct, and specifically 1 over 1. We get that from in front of my absolute value. If there isn't a number there, it's just 1. Okay? So we're going to go up 1, right 1, up 1, left 1, and we're going to do that a few times because we want to make sure our line is as perfect as possible. And then we're going to use some type of straight edge to draw our line or lines. Okay, and then don't forget to label that as f of x. So next we have g of x, and for g of x, what is my equation? Good, y equals 3. So we're going to go up to positive 3 and draw our line. And we have g of x. Okay, so we're going to wait there for a minute, but specifically we can see the points of intersection. Okay, so we have a point of intersection, it looks like right here, and also over here. If we go over here to A, it says highlight the portion of g of x where f of x is greater than g of x, and state the interval along the x-axis. So we're highlighting g of x, okay? So we're going to highlight on my green line, okay? And we want to highlight where f of x is bigger than g of x. And I feel like this is slightly confusing sometimes, so I'm going to do my best to help you understand. Where do you, like thinking about this, and maybe talk about it in your groups, where, without highlighting, where do you think you're going to highlight on the green line? And here are highlighters for anybody that needs them. Okay, so did you guys decide? Where do you think? So we're looking at this line, okay? Do you think we're going to highlight in the middle, or am I going to highlight on the outsides? On the outsides is correct. So do you see how here f of x is below the g of x line? Okay, and here, up here, that is where f of x is above the g line. Yes? And so if we are highlighting where f of x is greater than g of x, we are highlighting here on that outside mark.
Wait, why are you highlighting the left one?
Do you see how still right here f of x is above the g of x line?
Yeah.
So f of x is greater than g of x at this point, and it's also greater than g of x over here. So we're highlighting any part of the graph where it's bigger. Do you guys want to ask me more questions? So they only want us to highlight g of x. So that means I'm only going to highlight on my g of x line. Okay? And then they specifically said on the g of x line, only highlight the portion where f of x is greater than g of x. You could also write it like this, where g of x is less than f of x. You can think about that either way. So here, this is the portion where g of x is less than f of x, and same over here. Okay, that means these both mean the same thing. F of x is greater than, or g of x is less. Okay, and so if you're looking at this, what are the intervals that are highlighted? So going from left to right, it's from negative infinity to what value? A negative 5. And then it's from positive 5 to positive infinity. Do you guys see where it's highlighted in those portions? Okay, so now we're going to look at this algebraically. So f of x, if we look here, f of x is greater than g of x. How will I write that equation? What do I write for f of x?
X
Very good. The absolute value of x minus 2 is greater than g of x, which is 3. Is the absolute value by itself? No. Okay, I see the absolute value, but there's a minus 2 here with the absolute value. Okay, so how do I eliminate that? Very good. Add 2 to both sides. So when I do that, I get the absolute value of x is greater than, and 3 plus 2 is 5. Okay, now I want us to make a note, and I think we might make it up here so we don't forget it. But remember, if you multiply or divide by a negative, what do you have to do to your inequality sign?
Flip it.
Good. You must flip the inequality sign. So just like when we had our equal to sign, when we have this one, we have to do a positive and a negative. So I'm going to go ahead and make my 2 equations because I can make them now because the absolute value is by itself. And so we have the absolute value of x is greater than 5. So that's my one equation. But the other equation, and actually, you know what? We don't write absolute values now. Sorry. So when we're writing our 2 equations, we take away the absolute values. Okay, so the other side is going to be x is what? So this side is going to be less than negative 5. And the reason is because we basically are multiplying by a negative. And so whenever you're doing the negative part of the equation, you have to flip your inequality sign. Okay, if you look back at this original problem, see how it's saying it's a great or than sign? So it would make sense that we're going to have 2 separate graphs. We're going to have x is greater than 5 or x is less than negative 5. And so, again, and if you look over here, this has x is greater than 5, and over here this has x is less than negative 5. So we were able to get the same answers graphically and also algebraically. Do you want to ask me any questions before we try the next example? Okay, let's move on then. Okay, so this one starts f of x equals negative 3. And so what type of equation is that? So this one right here, what am I going to do? Good, y equals negative 3. So we're going to go on our graph. We're going to go to negative 3, and we are going to draw our line. And mine is not very good. Hopefully you can do better. Okay, so that is f of x. Next we have g of x. And for g of x, what is my vertex? Negative 4, 0 is correct. So again, with the x, we set that equal to 0, which is how I get the negative 4 for x. And notice how there's nothing at the end being added, so the y value is 0. So we're going to go negative 4, 0 and mark our point. What is my slope for my g of x equation?
Negative 1 over 1.
Very good, negative 1 over 1. So notice in front there's a negative sign. If there isn't a number with it, it's a negative 1. And then we put it over 1. So from this point, negative 4, 0, we're going down 1, right 1, down 1, left 1. And we're going to keep going until I hit this line to make sure it's accurate. We can draw our lines. And we're going to label that also as g of x. And we can see where they are overlapping here. So I'm just going to kind of circle those points to remind me what's happening there. And so let's go to A and read. And it says, highlight the portion of f of x. So notice this time we're highlighting f of x. Do you guys see that? Where g of x is greater than f of x. Okay, so in your groups, discuss where are you going to highlight on this pink line, my f of x line, where are you going to highlight where g of x is greater than f of x? Does anybody want an index card for drawing lines? Okay, so what do you guys think? Where are you highlighting on the pink line? Are you highlighting in the middle or are you highlighting on the outsides? Okay, the middle is correct. Okay, so do you see, okay, so right here it says where g of x is bigger than f of x. So if you're looking at this f of x line, do you see how right here that is where g of x is bigger than f of x, where it's above it? Down here is where g of x is below the line. So we're highlighting on f of x where g of x is above. So this is the only point here. This is where, that's where g of x is bigger.
Is that for every single one too? Where g of x is bigger than f of x?
And they'll tell you. So our last time said where f of x was bigger than g of x. So you just have to read what it says. Okay? Okay, so what would we write here to describe what's going on? And also notice that it has the equal to sign. And so should these actually be open circles or closed circles? Closed. And so I might go and close these circles to remind me that those are actually closed circles on there. And how would I write that in interval notation?
-7.
Bracket -7 to
-1.
-1 bracket. Very good. And again, we're using the brackets because it's equal to.
That's close.
Say that again.
Is it close?
Yes. Yeah. And it's included because of the equal to sign.
Oh.
Okay? Yes.
Wait, what did you highlight in the middle?
So back here, it says highlight the portion of f of x. So we're highlighting the line because that's f of x, where g of x is greater than or equal to f of x. So if you're looking at this line right here, okay, they wanted us to highlight where g of x is greater. Do you see how g of x is above the line? So I could only highlight that portion where g of x was above the f of x line. If this had said g of x, let me just write kind of here. If it had said g of x is less than or equal to f of x, highlight that portion, I would have flipped this around and I would have only highlighted the outsides because see how g of x is below the f of x line on the outsides, and so I would have highlighted the two outside marks. Yes?
Okay, one here says that it's greater than, and up here says it's greater than 4, and the or shows outside.
It depends on how we can rewrite it over here in just a minute so you can see. Okay, so let's check, but I understand what you're saying. Okay? And this maybe should have been flipped around right here. But let's see what happens when we write it, okay? Because I'm going to show you what happens when we write it. Let me answer one more question and then I'll come back to you. Yes?
For the first one, so it was supposed to be open circle?
Yes, the first one was supposed to be open circles. Okay, so when I write this equation, okay, it says g of x, which is negative absolute value of x plus 4, is greater than or equal to negative 3. Okay, now what do I have to do to get the absolute value by itself? Divide by -1. Good. So we're going to divide by -1 to both sides. And what happens when I divide by a negative? So we get absolute value of x plus 4. Two negatives make a positive. And what do I do with that inequality sign? Switch it. So it's going to be what? Less than or equal to 3. You can't make a decision on anything until the absolute value is by itself. So do you see how this is an and problem? So you can't decide if it's overlapping or if it's the separate two equations until your absolute value is by itself. Okay? So at this point now, this is when we would write our two equations. And we can also see that this is a less than sign, which means it's an and, which means it's where they're overlapping. Okay, when we set up our two equations now, we're going to have x plus 4 is less than or equal to 3. And then my other equation will be what?
X plus 4 is less than or equal to
Close.
Greater than
Good, greater than or equal to -3. So now we solve. I subtract 4 to both sides. And I get x is less than or equal to, good, -1. Over here I subtract 4 to both sides. And I get x is greater than or equal to -7. Good. Now, when you are writing this answer, we can tell that it's overlapping. We know that it's an and problem. And so you always write your answer from smallest to greatest. I can't spell greatest. There we go. With less than signs. And so what is the smallest number here? So it's going to be -7 is less than or equal to x is less than or equal to -1. In this case, it was less than or equal to signs. But you always write smallest to greatest, and that's saying it's the area where it's overlapping between -7 and -1, which is what we saw here as well. Those we will, if you were to use greater than or equal to signs, you would want to write your numbers from biggest to smallest, but we normally just always write it from smallest to biggest. Okay? Any questions there? Okay, moving on. We're going to do a couple more examples. 3 to be exact, so we're only going to do 2 of the 4 I have here. And so, actually we need to do 3. Okay, we're going to start here. What would I do first? Add 1. Good. We cannot set up 2 equations until the absolute value is by itself. So now I have absolute value of 3/4 x is greater than or equal to 6. Notice how the absolute value is by itself. Now I can set up my 2 equations. Okay? So this is where I set my 2 equations. I have 3/4 x is greater than or equal to 6. And what's my other equation? Less than or equal to -6. Also, what type of problem do we think this is going to be? So once the absolute value is by itself, this is a great or. So always read it from left to right. This is an or problem, great or. Okay, how do I eliminate the fractions? Multiply by the reciprocal. So I'm multiplying by 4/3 here to both sides. That eliminates my fraction. I get x is greater than or equal to. What happens with the 3 and the 6? Can I reduce those? Because that 6 is basically over 1. We can write it over 1. And 3 goes into 6 2 times, and 2 times 4 is 8. Okay, over here, I'm going to do the same thing. I'm going to multiply by the reciprocal, which is 4/3 to both sides. That eliminates my fractions here on the left. And we get x is less than or equal to, I reduce the 3 and the 6, and negative 2 times 4 is, so on your graph, we go smallest to biggest. So we have a negative 8 and a positive 8. Notice at positive 8, it should be a solid point, and it's going to the right or left? The right. The greater than values go to the right. At negative 8, it should be a solid circle, and it's going to the left because left is less than. And if you would rather like highlight, you can. Do you see how there are two separate answers there for this one? And that's also how you would write your answer. They did, though, ask us to write our solution in interval notation. So how would I write this in interval notation? Negative infinity to negative 8. And then the union of 8. Oh, and sorry, this was supposed to be a bracket. And I can't write an 8. Oh my goodness. And then 8 to positive infinity. I'm not sure what it is. So, sorry. Pretend that's an 8. I'll rewrite it one more time. Negative infinity to negative 8. 8s and infinities are hard to write at the same time. Okay. All right. Any questions there? Okay. Next one. Is the absolute value by itself? No. What do I do? Multiply by the reciprocal, which is negative 3 over 2, and whatever I do to one side, I have to do to the other side. That eliminates those. I have the absolute value of 3x plus 1, and whenever I multiply or divide by a negative, I have to do what? Flip the inequality sign. Good. And so here, we can reduce. 2 goes into 6 3 times, and 3 times negative 3 equals, okay, whenever you get a negative number on this side, you need to stop, okay? It's either going to be no solution or all solutions, okay? So at this point, and this is how I think about it, the absolute value will always give me a positive answer, and is a positive less than a negative? No. So the answer is what? No solution, and it asks you to give a reason why. So my answer is no solution. Okay, very good. Absolute, actually, I think I'm just going to write that a positive is not less than a negative. And you don't have to write it exactly how I did, but you just want to give some kind of written explanation as to why that is no solution. Okay. Other side, what am I going to do first?
Minus 7.
First, subtract 7. Okay? 1/2. Absolute value of 4x minus 2 is greater than or equal to, and what is 4 minus 7? Negative 3. Very good. What will I do next? Multiply by the reciprocal, which is 2 over 1. Okay, when I do that, I get the absolute value of 4x minus 2 is greater than or equal to negative 6. How come I didn't flip the inequality sign on this one? Good. I didn't multiply or divide by negative. I multiplied by 2, right? Okay. Again, though, I have a negative number here. So always when I have a negative number, I need to stop. Okay? Is a positive greater than or equal to a negative? Yes. So this one means it's all solutions. So you can write all real numbers. You can write all solutions, whatever you choose. And again, my written reasoning would be that a positive is greater than a negative. Okay? And since this one's all solutions, for interval notation, This should be negative infinity all the way to positive infinity. And so that is how we would write that in our interval notation. Okay, any questions?